everyone, this is Kalpana here. In this video, we are going to see a problem from Mathematical Induction. So let's get started. Problem. Using the principle of Mathematical Induction, prove that 1 into 3 plus 3 into 5 plus 5 into 7 plus so on plus 2n minus 1 into 2n plus 1 is equals to 1 by 3 into n into 4n square plus 6n minus 1. Right? Solution. Let the given statement be P of n. Then P of n such that 1 into 3 plus 3 into 5 plus 5 into 7 plus so on plus 2n minus 1 into 2n plus 1 equals to 1 by 3 into n into 4n square plus 6n minus 1. Okay. So firstly we'll prove for n equals to 1, n equals to 2, and we'll assume that the statement is true for n equals to k, and finally we'll prove for n equals to k plus 1. Okay. When n equals to 1, that means in the LHS, when n equals to 1, you take the first term. When n equals to 2, you'll take, see you're having first term, second term, third term, plus so on, plus n term, right? So when n equals to 1, if you substitute n equals to 1 in, if you take tn, that is nth term, you're having 2n minus 1 into 2n plus 1. If you put n equals to 1, then you'll get t1. See? 2 into 1 minus 1 into 2 into 1 plus 1, which is equals to 2 into 1, 2 minus 1 into 2 into 1, 2 plus 1, which is equals to 2 minus 1 is 1 into 3. Okay? T1. When n equals to 2, two into 2 minus 1 into 2 into 2 plus 1 equals to 2 2s are 4, 4 minus 1 into 2 2s are 4, 4 plus 1, which is equals to 4 minus 1, 3 into 4 plus 1, 5. Second term. Okay, fine. When n equals to 1, we'll take first term. When n equals to 2, we'll take the sum of two terms, that is t1 plus t2. When n equals to 3, we'll take the first three terms, t1 plus t2 plus t3. Likewise, when n equals to k, we'll take first k terms. Similarly, when n equals to k plus 1, we'll take first k plus 1 terms. Okay? Fine. But while coming to RHS, you'll simply substitute n equals to 1 if you want. Only one term you'll get, okay? In the LHS, you're having number of terms. But in the RHS, you're having only single term, right? You'll get the direct answer. Fine. Now, when n equals to 1, LHS 1 into 3, which is equals to 1 3s are 3. N equals to 1 is nothing but number of only one term. Okay, when n equals to 2, you'll say sum of two terms. You'll take n sum of two terms. When n equals to 3, you'll take sum of three terms. Okay, fine. Now coming to RHS of when n equals to 1, you'll get 1 by 3 into, simply substitute n equals to 1, then you'll get 1 by 3 into 1 into 4 into 1 square plus 6 into 1 minus 1, which is equals to 1 by 3 into 4 into 1 square is 4 plus 6 into 1 is 6 minus 1. This is equals to 1 by 3 into 4 plus 6 is 10 minus 1, which is equals to 1 by 3 into 9. 3 ones are 3 threes are 3. Okay, LHS equals to RHS. Therefore, LHS equals to RHS, which means that P of n, therefore P of n is true for n equals to 1. Therefore, P of 1 is true. If you want, you can check for n equals to 2, or directly you can assume the statement is true for n equals to k. So let's check. Okay, let's check what happens when n equals to 2. When n equals to 2, LHS, take the first two terms, sum of two terms, that is t1 plus t2 is 1 into 3 plus 3 into 5, which is equals to 1 3 is 3, plus 3 5s 15, which is equals to 18, right? Coming to RHS, you'll get 1 by 3 into, when n equals to 2, right? Simply substitute n equals to 2. 1 by 3 into. Now substitute n equals to 2 in RHS, then you'll get 1 by 3 into 2 or 4 into 2 squared plus 6 into 2 minus 1. To 2. Fine. 4 into 2 2's 4 plus 6 2's are 12 minus 1. So this equals to 1 by 3 into 2 into 4 4's are 16 plus 12 minus 1 11. So this equals to 1 by 3 into 2 into 16 plus 11 is 27, right? 3 1's are 3 9's are. Again, 2 9's are 18. So here LHS is equals to RHS. Therefore, LHS equals to RHS, which is nothing but P of n is true for n equals to 2. Therefore, P of 2 is true. Okay. Likewise, you can check for n equals to 3. When n equals to 3, you'll take first 3 terms from LHS, and while coming to RHS, you'll simply substitute n equals to 3. You can check for n equals to 3, 4, 5, 6, so on. Okay, it's up to you. Now, assume that P of n is true for some k belongs to natural numbers. Then P of k is such that 1 into 3 plus 3 into 5 plus 5 into 7 plus so on, plus we'll simply take first k terms, 2 into k minus 1 into 2 into k plus 1 is equals to 1 by 3 into k. Simply substitute n equals to k, then you'll get 1 by 3 into k into 4k squared plus 6k minus 1. Okay, so now we have to prove for n equals to k plus 1. Now, take first k plus 1 terms, 1 by 3 plus 3 into 5, 1 into 3 plus 3 into 5 plus 5 into 7 plus so on, plus kth term is 2k minus 1 into 2k plus 1 plus k plus 1th term is 2 into, simply substitute n equals to k plus 1, then you'll get 2 into k plus 1, 2 of k plus 1 minus 1 into 2 of k plus 1 plus 1. Okay? So this equals to, now we can replace it by p of k plus 1, which is equals to 1 by 3 into k into 4k squared plus 6k minus 1. Okay? Plus 2 into k is 2k plus 2 into 1 is 2 minus 1 into 2 into k is 2k plus 2 into 1, 2 plus 1. Okay? So let it be. Okay, see this is your RHS term, right? We'll simply put n equals to k plus 1. Let's see what happens when we substitute n equals to k plus 1 in this term. Then you'll get 1 by 3 into k plus 1 into 4 into k plus 1 whole square plus 6 into k plus 1 minus 1, right? So this equals to 1 by 3 into k plus 1 of 4 into expand k plus 1 whole square, k square plus 1 plus 2k plus 6k, 6 into k 6k plus 6 into 1 6 minus 1. This is equals to 1 by 3 into k plus 1 into 4k square plus 4 plus 2 4s are 8k plus 6k plus 6 minus 1 is 5. This is equals to 1 by 3 into k plus 1 into 4k square. Now add k terms. 8 plus 6 is 14. 14k plus 4 plus 5 is 9. Okay. Now coming to this step. This is equals to 1 by 3 into k into 4k square plus 6k minus 1 plus 2k plus 2 minus 1 is 1 into 2k plus 2 plus 1 is 3. This is equals to 1 by 3 into k into 4k square is 4k cube plus 6k into k is 6k square minus 1 into k is minus k plus 2k into 2k is 4k square plus 3 into 2k is 3 2s are 6k plus 1 into 2k is 2k plus 1 into 3 is 3. So this equals to 1 by 3 into 4k cube plus 6k square minus k plus 4k square plus 6k plus 2k is 8k plus 3. So here you can multiply and divide by 3. Multiply and divide 3. Okay, since you're having 1 by 3 here in the first term, we don't have any 1 by 3 here. So what we are doing is we'll simply multiplying 3 and dividing 3. Okay. So in the next step, you can take 1 by 3 common from these two steps. Then you'll get 1 by 3 Now we are taking 1 by 3 common from these two steps. We'll get 1 by 3 into 4k cube plus 6k square minus k plus 3 into 4k square plus 8k plus 3. So this is equals to 1 by 3 into 4k cube plus 6k square minus k plus 3 4s are 12k square plus 3 8s are 24k plus 3 3s are 9. This is equals to 1 by 3 into 4k cube. Now add k square terms. 6 plus 12 is 18k square. 24k minus k is plus 23k plus 9. Okay. Fine. Now coming to this step. If you simplify this, you'll get 1 by 3 into k into k 4k square plus 14k plus 9 plus 1 into 4k square plus 14k plus 9, which is equals to 1 by 3 into k into 4k square is 4k cube plus 14k into k is 14k square plus 9 into k is 9k plus 1 into 4k square is 4k square plus 14k plus 9. So this equals to this equals to 1 by 3 into 4k cube plus 14k square plus 4k. 14k square plus 4k square is 18k square. 9k plus 14k is 9 plus 4 13. 1 plus 1 2. That is plus 23k plus 9. Right? So here, in order to get RHS in terms of k plus 1, what we can do is we'll simply see these two are same, right? There is nothing but 1 by 3 into k plus 1 into 4 into k plus 1 whole square plus 6 into k plus 1 minus 1. You can directly replace this by this, or you can write in the reverse direction. See? Simply you could write it as 1 by 3 into, I'll write the step, or you can write this, or you can write from the beginning, okay, from backward. So this equals to 1 by 3 into 4 plus 1 into 4k square plus 14k plus 9, which is equals to 1 by 3 into, I'm directly writing the first step, 4 into k plus 1 whole square plus 6 into k plus 1 minus 1. See? The same step for n equals to k plus 1. 1 by 3 into n into 4 into n square plus 6 into n minus 1. So this completes the problem. That is, therefore, p of k plus 1 such that 1 into 3 plus 3 into 5 plus 5 into 7 plus so on plus kth term 2k minus 1 into 2k plus 1 plus k plus 1th term 2 into k plus 1 minus 1 into 2 into k plus 1 plus 1 is equals to 1 by 3 into k plus 1 into 4 into k plus 1 whole square plus 6 into k plus 1 minus 1. Therefore, P of k plus 1 is true whenever P of k is true. Thus, P of 1 is true, P of 2 is true, and P of k plus 1 is true whenever P of k is true. Right? Therefore, by the principle of mathematical induction, the given statement is true. For all n belongs to natural numbers. So this completes the problem. So this is all for now. Hope you'll understand. We'll see you in the next video. Until then, bye bye.